I am Dr. L Madhuchelvi, Associate Professor of Mathematics, Sri Sharada College for Women, Salem. In this lecture, we will discuss about the gradient of a scalar point function. Gradient of a scalar point function. First, let us see the definition of a gradient of a scalar point function. Let us see the definition of directional derivative of a scalar point function first. The directional derivative of a scalar point function phi at a point P in a direction is the scalar function limit P dash tends to P phi of P dash minus phi of P by P dash, where P dash is a point such that the direction of P dash is same as direction in cosine. First, let us see the statement of bookwork, because we are going to focus on the problems on gradient of a scalar point function. So let us see only the statements. The directional derivative of phi of x, y, z at the point P of x, y, z in the direction specified by the directional cosines L, M, N is L dou phi by dou x plus M dou phi by dou y plus N dou phi by dou z. And then gradient of a scalar point function. What is called the gradient of a scalar point function? The definition is, if phi is a scalar point function, then the vector dou phi by dou xi plus dou phi by dou yj plus dou phi by dou zk is called the gradient of phi. This vector is written as grade phi or del phi, where del stands for I dou by dou x plus j dou by dou y plus k dou by dou z. Then next bookwork statement is the directional derivative of phi in the direction specified by the unit vector E is del phi dot E. Let us go to the problems now. The problem on directional derivative. Find the directional derivative of x plus xy square plus yz cube at the point 0, 1, 1 in the direction whose direction cosines are 2 by 3, 2 by 3 minus 1 by 3. So first, the directional derivative is phi equal to x plus xy square plus yz cube at the point 0, 1, 1 in the direction of whose direction cosines are 2 by 3, 2 by 3 minus 1 by 3. Let phi equal to x plus x, y square plus y z cube, directional derivative equal to L dou phi by dou x plus M dou phi by dou y plus N dou phi by dou z. That is equal to 2 by 3, 1 plus y square plus, that is L is 2 by 3. Dou phi by dou x is, if you differentiate phi with respect to x, we get 1 plus y square plus 2 by 3 into dou phi by dou y is 2xy plus z cube. Then plus n into dou phi by dou z, n is minus 1 by 3. So minus 1 by 3 into 3y z square. That is differentiating this one with respect to z, we are getting 3y z square. Then at the point 0, 1, 1, the directional derivative is 2 by 3 into 2 plus 2 by 3. That is, if you substitute for x0, y1, z1, we get 1 plus 1, that is 2, and then 2 by 3 into x is 0, so that 0, here second one is z cube, z is 1, so 1, 2 by 3 minus 1 by 3 into 3. So that is 4 by 3 plus 2 by 3 minus 1, that is 2 minus 1 equal to 1. Find del phi at xyz if phi equal to x plus xy squared plus yz cube, del phi equal to dou phi by dou xi plus dou phi by dou yj plus dou phi by dou zk. Then dou phi by dou x is, here we get 1 plus y squared. So 1 plus y squared I plus 2xy plus z cube. With respect to y, if you differentiate, we are getting this one, 2xy plus z cube j, plus with respect to z, we get 3yz squared k. So del phi at xyz is 1 plus y squared I plus 2xy plus z cube j plus 3yz squared k. Next problem is, if r is given that xi plus yj plus zk and modulus of r is r, that is, if r is the position vector of a variable point x, y, z, then we have to prove that del of log r equal to r by r squared first. So del of log r equal to r by r squared, we will show. Given r is a position vector of x, y, z. So r equal to xi plus yj plus zk. So what is r squared? R dot r. That is r squared, that is equal to x squared plus y squared plus z squared. If you differentiate with respect to r, we get 2r, dou r by dou x equal to 2x, dou r by dou x equal to x by r. Similarly, dou r by dou y equal to y by r, dou r by dou z equal to z by r. Then we have to find del of log r. So del is I dou by dou x plus j dou by dou y plus k dou by dou z of log r. I into dou by dou x of log r is 1 by r or dou r by dou x plus j into dou by dou y of log r is 1 by r or dou r by dou y plus k into dou by dou z of log r is 1 by r or dou r by dou z. So I into 1 by r, dou r by dou x, already we found that dou r by dou x is x by r. So let us substitute here x by r plus j into 1 by r, dou r by dou y is y by r. So here we have to substitute y by r plus k into 1 by r into dou r by dou z is z by r. So let us substitute the values. We get I into x by r square plus j into y by r square plus k z by r square. Let us take 1 by r squared outside. Then we get xi plus yj plus zk. What is xi plus yj plus zk? This is r. So r by r squared. We found that r by r squared, that is equal to del of log r. Next one is del of r power n. We have to find del of r power n and prove that that is equal to r power n into r power n minus 1 r cap or n into r power n minus 2 r vector. So let us see the solution. Del of r power n equal to I dou by dou x plus j dou by dou y plus k dou by dou z of r power n. That is I dou r power n by dou x plus j dou r power n by dou y plus k dou r power n by dou z. That is I into dou r power n by dou x of r power n is n into r power n minus 1 dou r by dou x plus j into dou by dou y of r power n is n into r power n minus 1 into dou r by dou y plus k into dou by dou z of r power n is n into r power n minus 1 dou r by dou z. That is equal to n into r power n minus 1 I dou r by dou x plus j dou r by dou y plus k dou r by dou z. That is n into r power n minus 1 I dou r by dou x is x by r plus j dou r by dou y is y by r plus k dou r by dou z is z by r. that is equal to n into r power n minus 2 xi plus yj plus zk, that is r vector. So n into r power n minus 2 into r vector, that is one thing. Next we have to prove, that is we can simplify, that is r cap equal to r into r vector equal to r into r cap. So we are getting n into r power n minus 1 into r cap. So we proved that del of r power n equal to del of r power n equal to n into r power n minus 1 into r cap or n in r vector or n into r power n minus 2 into r vector. Next, we are going to prove del of r dot a equal to a vector. So, where a vector. So, here same del of r dot a. Yes. Del of r dot a is a equal to, let us say a1i plus a2j plus a3k. Then r vector is xi plus yj plus zk. R dot a is a1x plus, if you find the dot product, a1x plus a2y plus a3z. So del of r dot a is I dou by dou x. Del is I dou by dou x plus j dou by dou y plus k dou by dou z of a1x plus a2y plus a3z. That is equal to a1i plus a2j plus a3k. Find the dou by dou x of a1x is 1. So a1, so a1i. Second one, dou by dou y of a2y is a2, so a2j. The dou by dou z of a3z is a3, so a3k. That is equal to a vector. Then second thing we have to prove is del of box product of RAB equal to A cross B. But we know that the box product of RAB equal to R vector, A vector, B vector equal to R dot A cross B. So del of R dot, in place of box vector RAB, we can substitute R dot A cross B. That is equal to, now only we proved that del of R dot A equal to A. So here if you apply that result, we get A cross B. Required result. Second one, we have to prove del of A dot R equal to 2A, where A equal to alpha xi plus beta yj plus gamma zk. So A dot R is alpha xi plus beta yj plus gamma zk dot xi plus yj plus zk. That is equal to alpha x squared plus beta y square plus gamma z square. So del of A dot R is I dou by dou x plus j dou by dou y plus k dou by dou z of alpha x square plus beta y square plus gamma z square. That is equal to I to alpha x plus j to beta y plus k to gamma z. That is 2, let us take 2 outside, then 2 alpha 2 xi plus beta alpha xi plus beta yj plus gamma zk. 2 into what is alpha xi plus beta yj plus gamma zk? That is a. So 2a. So we got del of a dot r equal to 2a. The next problem is here, the problem number, that is 4, that is in the book. That is where to find the phi is given that 8x y square minus x squared y z at the point 1, 2, 3, and in the direction specified by the vector I minus 2j plus 2k. Here we are going to apply the formula to find the del phi dot e, del phi dot e, to find the directional derivative of phi, del phi dot e, using that bookwork. So first let us find the unit vector corresponding to I minus 2j plus 2k, the given vector. Yes, I minus 2j plus 2k by, that is r vector by modulus of r, that is only the unit vector corresponding to the given vector. So I minus 2j plus 2k by root of 1 plus 4 plus 4, that is I minus 2j plus 2k by 3. So it is del phi. So the del phi equal to I into, what is that? We have the formula del phi is dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. So I 3x y square minus x square y z is 5. So dou phi by dou x is that is 3y square minus 2xyz plus j dou phi by dou y is 6xy minus x squared z plus k dou phi by dou z is minus x squared y. Then del phi at 1, 2, 3 years. At the point 1, 2, 3 years, let us substitute for x1, y2 and z3. We get I 12 here, 3 into 2 square, that is 12 minus 2 into 1 into 2 into 3, that is 12, plus j 6 into 1 into 2, that is 12 minus 1 square into 3, that is 3, plus k into minus 1 squared 2, that is minus 2. So here first one is 0i plus 9j minus 2k, that is del phi. Then directional derivative of phi is del phi dot e, that is 9j minus 2k dot I minus 2j plus 2k by 3. So by using the dot product, we get 9 minus 2, 9 into minus 2 minus 18, minus 2 into plus 2 minus 4 by 3. That is equal to minus 22 by 3. That is the answer. That is the directional derivative of phi is minus 22 by 3. The next problem is, if del phi equal to 6r minus 8r squared r vector, then phi of 2 is 4, find phi. We have to find the phi. Del phi is given and value of phi at 2 is given. We have to find phi. So we know that r equal to r into r cap. So del phi equal to 6r minus 8r squared into r cap. That is 6r squared minus 8r cube into, that is you multiply by r and we are getting r cap only. Then but del of phi of r is pi dash of r into r cap. So using that, here we have phi dash of r equal to into r cap equal to 6r squared minus 8r cube into r cap. We can cancel that r cap and on both sides. Then we get phi dash of r equal to 6r squared minus 8r cube. So phi of r, we need phi of r, that is we have to integrate that 6r squared minus 8r cube. We are getting that 6r cube by 3 plus minus 8r power 4 by 4 plus the integral constant c, that is 2r cube minus 2r power 4 plus c. But given that the value of phi at 2 equal to 4, so we know phi of 2 equal to 4. So if you substitute in place of r equal to 2, we are getting phi of 2 equal to 2 into 2 cube, that is 8, minus 2 into r power 4, that is 8, what do you have that, 2 power 4, 16. So 2 into 8 minus 2 into 16 plus c, that is 16 minus 32 plus c, that is equal to minus 16 plus c equal to phi of 2. Given that 4, let us substitute here, minus 16 plus c equal to 4, that is c equal to 20. So phi equal to 2r cube minus 2r power 4 plus 20. If you take 2 outside, we get r cube minus r power 4 plus 10. So in this lecture, we saw the definition of a directional derivative and a gradient of a scalar point function, and then some problems on gradient of scalar point function. Thank you.